So remember that there's 3 tests for an inverse. The first, based on the graph, is called the what? Horizontal line test. The second, based on the equation, is x can't be squared or an absolute value. The third was based on points.
Wait, I thought it was x can't be raised to an even power.
Yeah, sorry, squared or even power, yeah. The third is the points, which is what? Other way around. The y can't be with a different x. Okay? So it would have to be both because it has to be a function to be also inverse. So remember, 1 to 1 means it's both. Like for every one x, there's one y. Every one y, there's one x. So is number one, or does it have an inverse? Is it 1 to 1? No. 2? No. 3? Yes. Okay. 4? No. 5?
Yes.
See how easy this is? 6?
Wasn't the third one not past the horizontal?
No. None of those horizontal lines hit it more than 1 point. 6, find the inverse of the function. Step 1. Good. Make f of x the y. Step 2. Switch the x and the y. Step 3. Solve for the new y. Last step. Has to switch it back. That is no longer the same equation. You cannot leave it that way. You can use either one of those. X over 5, or x minus 5 over 2, or x over 2 minus 5 over 2. Obviously, if I had asked you to graph the inverse, or graph the original and the inverse, you would have to split that so that it's a line and graph it.
Could you have put 1/2 x?
Sure. How'd we do? Great. Okay, this, you're going to get mad because this is so much easier than it looks, but it is confusing. This was question 10, and a lot of people had questions on it. If I have an original function, which is this, and I wanted to find the inverse coordinate points, what do I do with those coordinate points? I switch them. So it'd be 6, -3, 0, -1, -2, 2, and -3, 4. Then this chart is saying, okay, if this is the x, find the new y that matches it. So -3 is here. The coordinate point that matches should be 4 once you switch it.
I needed help, like, graph it. Yeah.
Oh, is that what it was? Is the graph?
Like, I just don't know how to use the website.
Oh, so sometimes it's so glitchy. And to be honest, you're never going to test on WebAssign graphs. So I'm totally fine with you just sticking to Notability. But when you graph, so this ended up being, what was it? A parabola, right? Oh, so you have to tap point. Like the tools over here.
Well, I did was I pressed the 4 points, and there's a thing that has like a line segment, and then you can just tap on
Yeah.
it.
But I'm telling you right now, like I know you need the green check, but I would rather you be graphing this on Notability than on WebAssign. Because one, it's glitchy. Like sometimes it works perfectly. 1 year we had no issues with the iPad, and then the next year they changed their interface and it would not work with the iPad. So if you can get it to work, fantastic. Do not spend more than 30 seconds trying to figure it out. Move on and go to Notability. When you're graphing your quadratics, like if you have a quadratic that needs to be graphed today, do it by hand, Notability. You're not going to be graphing on your WebAssign for your test or your quiz. I'd rather you graph by hand and get that point wrong. I know I assigned a graph for that. Like, so when I'm looking at your little box, I know number 3 is a graph. So if it's got an X in it, I'm fine.
So even if we don't answer it on WebAssign, we don't reach the 80 because we didn't answer those graphs.
So I basically look at, that's why I get your little box of results. If number 3 is what you got wrong, I go find your number 3. If your number 3 on your PDF has the work and it's just like a simple mistake or something like that, then I still give you back the credit. Yep.
Could you read them by number?
Oh, yeah. Mine says determine if it's, wait, you got it right. Oh, this isn't yours. So you knew it was a function, right? Then you want to go find it, right? So y would equal square root of x minus 7 to get rid, and then switch the x and y's. And then to get rid of the square root, we got to square both sides. And then you want to get rid of the 7. It was a parabola, right? Oh, no, this is the different one. So this one is interesting. Like when you go to graph this, if you want to try it, because I know some people just like that stuff, 3, 4, 5, 6, 7, you just want that green check. When you graph this on WebAssign, you tap the parabola in which direction you want it to be, which was up, or even up or down, doesn't matter, but up. You tap that little tool, you tap this dot, and then you have to give it at least one other dot. and it will reflect it. So if I plugged in 1 here, I would have gotten 8. So if I tapped 1, 8, it would actually draw the parabola for you. But again, not using WebAssign to take your test or quiz, so I don't need you to perfect the graphing on WebAssign. Is it a great tool to use for next year or the year after when you're going into college? Probably, okay, because they're not going to care about your PDF. But for right now, don't stress about it. Yeah, sure. Okay, we're going to finish 2-1. So a quick glimpse at what we covered yesterday, which was this form we called quadratic form. Okay, remember there's 2 forms that we're going to look at, quadratic and standard. Quadratic has an x squared and an x. That's how we know the difference between them. The standard will just have a single variable, whether that's an x squared or x plus or minus something in parentheses squared. You'll only see x appear once. That's how we know the difference, okay? So we said obviously it's a parabola. It's shaped like a U. The axis of symmetry is the line, that vertical line that runs directly through the vertex. We said if it's a negative x squared, it opens downward and it would have a maximum. If it's a positive x squared, it opens upward, would have a minimum. Which is that? We graphed this one. We shifted it to the left 1 unit. We plotted the point to the left of it and to the right of it. So it was here. And then I think it was this one, this one. Oh, no, it was narrow. So it would have been 4, I think is what we got.
No.
Was that right? Yeah? Okay. But we plotted the actual points, right? Like we found -2 and we plugged in -2 and plugged in 0 and got those points because we had to take it a little bit more specific than we've been used to with the transformation. There are 2 forms, right, of quadratic. We said there's quadratic form, which would be that ax squared plus bx plus c. And then there's standard form. You'll know the difference by the number of x's in your equation. If you have an x and an x squared, it's quadratic. If you just have the x, whether it's squared by itself or it's in parentheses with a number and then squared, that's standard form, okay? We're going to learn how to graph both, how to find the information from both kinds, and there are different approaches based on what it is. If it's in standard form, then I can simply just grab the HK from my equation. Whatever's inside the parentheses, we change the sign on it. So if it was a -3, then my H is just 3. If it was a +3, it's -3. The K, we leave the sign. Because if you think about it based on your transformations, what was inside the parentheses, we moved in the opposite direction, right? If it was a plus, we moved to the left. If it was a minus, we moved to the right. It was opposite. But the K, the number that was by itself, the shift up and down, we kept true. If it was positive, we moved up. If it was negative, we moved down. From that information, we can also determine our axis of symmetry, okay? Which is x equals whatever the h coordinate is of my vertex. So once I know my vertex, I also know my axis of symmetry. It has to be x equals, so I will dock points for that as well. It's got to be x equals because it's an equation, it's a line, it's not just a point, okay? So you can't say axis of symmetry is 3. It has to be x equals 3. Okay, if it's in standard form and we're graphing it, we're going to approach it this way. The first thing we're going to do is look at it and determine does it open up or does it open down. Positive x squared, it opens up. Negative x squared, it opens down. Then we're going to find the vertex, which is that HK, and then we're going to find the intercepts. So for the x-intercept, we plug 0 in for y. For the y-intercept, we plug 0 in for x. We're going to plot those intercepts. We're going to plot the vertex. And if that's enough information, we're going to go ahead and do the graph. If there's not enough information from that, because maybe there's no x-intercepts, then we'd have to plot extra points. You need, at minimum, 3 points. 1 being the vertex, and 1 to the right, and 1 to the left. So it has to be the vertex, 1 to the right, and 1 to the left. Let's graph this question. So tell me what you know about it based on its transformations. Say again. It's going to go 4 units up.
And left 2, and then it's going to be
Which way does it face? Down.
right?
So I already know that information. If you want to use that information, feel free to plot yourself a rough draft. Left 2, up 4, and it's going to point down. I still have to find more information than that. So the vertex, which I know either from the graph, that left 2, up 4, or opposite of what follows x and the number that's by itself, you can find the vertex either way, because sometimes you're going to do this without graphing, so you want to make sure you know how to do both. I know it opens downward. Now I need my x-intercepts, so I'm going to make y 0. I would subtract the 4, divide by -1, square root, remembering to put the plus and minus in front of the square root. Don't forget that, otherwise you lose a point. Like literally you can't find one of the points. X plus 2 would equal plus and minus 2. This means there's 2 equations here to solve. -2 equals x plus 2, and +2 equals x plus 2. So I subtract the 2. Oh, this should be positive, sorry. And x equals 0. So x-intercepts -4, 0, and 0, 0. Now I can make my graph a little bit more accurate. Now, it didn't specifically ask for it, but on your quiz, it will say, okay, now what are the y-intercepts? So it's going to say, what's the x-intercept? What's the y-intercept? So the y-intercept, I just have to plug 0 in for x. So -0 plus 2 squared plus 4, and I get -2 squared plus 4, which is -4 plus 4. And that's consistent with what we found for the x-intercept, right? If I get a 0, 0 for one of them, it means it's also for the other one. God bless you.
Thank you.
You're welcome.
Wait, so for the y-intercept,
You plug 0 in for x, right? But we already have it. Once you get 0, 0 for one of them, it's going to count for both. The question is, if I had started with y-intercept and got 0, 0, with x, it's 2. So you have to try it to make sure that there's not more than one. There's never going to be more than one y-intercept, because that would be a sideways parabola, which isn't going to happen with the functions. But if there's one x-intercept, there's 2 x-intercepts, because it has to cross through twice. Unless it's, well, I guess unless the vertex is there. That would be the only time it's not. All right, tell me the domain of this graph. All real numbers. Every single person in that room needs to know that answer, because that's an answer to a question on your quiz, right? What's the domain of every parabola? All real numbers. Okay, what's the range of this graph? -∞ up to 4. Good, with a bracket on the 4. Yep.
So whenever, like on the y-axis, like for the range, since here it's 4, it's always gonna have a bracket, right?
Yeah, there's never going to be an open dot on these parabolas. It's always a bracket. Always a parentheses on the infinities, but always a bracket on the, and it's always the k. It's always the y-axis, I mean the y coordinate of your vertex.
Okay.
The question is it at the top? Because then it's -∞ to that. If it's at the bottom, then it's that to +∞. You're welcome. Left off here, correct? Yes.
we did this one.
We did this one?
No, we did one before that.
All right, we ready? If you're close, I'm going to, well, even if you're close, I'm going to stop you because I'm going to go over it. Okay, so vertex is what? 3, -4. So important you change that sign. You screw that up, everything gets messed up. So you have to be really, really careful. How about, does this point up or down? Up. So first decision, up or down, then move on to vertex, right? So now I know it's 3, -4. 3, -4, plot my point, okay? Then I want to find x-intercepts. So I'm going to make the y the 0 or the f of x the 0. 0 equals x minus 3 squared minus 4. I add the 4. I square root both sides, putting that plus and minus in front of the 4. I get plus and minus 2. So there's a negative 2 equals x minus 3 equation here, and there's a positive 2 equals x minus 3 equation.
Wouldn't it have been negative? Oh, never mind.
You sure? Yeah? Okay, 1 equals x, and then 5 equals x. So my two x-intercepts are 1, 0, and 5, 0. Now I've got this, and I've got this. And I actually have enough information to already make my parabola, right? But it's going to ask for it anyway, so you might as well practice. The y-intercept, we plug 0 in for x, so y equals 0 minus 3 squared minus 4. Y equals negative 3 squared minus 4. 9 minus 4, which is 5. 0, 5. Which is all the way up here. So now I'm going to draw my parabola. If you want to reflect the point that is your intercept for your y-axis, feel free. You don't need it, but you can. If you look at the distance change between here and here, so we went up 5 and left 1, you would do the same thing over here, up 5, but I'd go to the right one. So if you want to reflect that point, you totally can, but you don't need it. Minimum 3 points, okay? But if you want it, you can totally do it.
Can I see when you look for the y?
Yeah, the green one.
Oh, I see.
So you don't have to show yourself crossing the y-intercept in the graph?
If, God bless you, if you have 3 points before that. Correct. Can I, so, oh yeah. Axis symmetry, sorry, Dylan.
You can find the x-intercept by factoring, right?
In this case, but when you factor, you move the 4 to the other side, is that what you're saying?
No, I subtracted
Did you-
by the 9. So I got the same answer.
You expanded?
Yeah, I kept
Oh.
what I solved.
So you did x squared minus 6x plus 9, and then you did it? Yes. If it factors.
Yeah.
It may not factor. If it doesn't factor, you're left with the quadratic if you put it in that form, the quadratic formula, which could happen, okay? And that's when the even root's probably easier. Because if let's say 4 wasn't a perfect square, I would leave it as square root 3. And then I would do plus and minus the other number, which we're going to see. But I think you can go back and forth between those two, but I think it's easier to use even root if it's set up for it and it's not factorable, which you'll know if this is not a perfect square. If the number by itself is not a perfect square, like when you move it over here, then it's not factorable. So you either continue on and this would stay as a square root, or you have to use the quadratic formula, which again we're going to review because you're going to have to use it at some point too. Mariana.
So how did you know that you could just reflect the y?
It's always reflected over the axis symmetry.
So it's symmetrical.
Always to the axis of symmetry, not to necessarily the y-axis, but to the axis symmetry.
Like this line is symmetrical.
That's the axis symmetry is always symmetrical. It is always symmetrical to the axis of symmetry, which runs right through the vertex, which is your x equals 3.
Oh, okay.
Yep,
So basically, like, you don't need to plug in the points unless there's
not enough. And there's going to be times where there's not x-intercepts.
Okay.
So you're going to have to plug in points. Like if this was shifted up, right? If this was above my x-axis, I've got no intercepts. Or if this is flipped down, I have no x-intercepts. And so you'd have to plug in extra points.
So here we just kind of like we're able to find the axis of symmetry by looking at it.
You're always able to find the axis of symmetry by looking at it.
But what if it's like decimal points?
You would go off of your vertex. It's always the x equals whatever's the opposite of what's in there. Because it's the x coordinate of your vertex. If it's in standard form. If it's not, we're going to talk about that in a little bit. This is standard form.
So you would look at that x minus and then it'd be the opposite?
Correct.
For
What? Oh.
Always?
If it's in standard form.
Okay.
Yep. What's domain? All y'all better know that answer. What's domain? Negative infinity to positive infinity. What's the range? Negative 4 to positive infinity. Good. Questions? Yeah.
You make the 4 vacuum.
Say again?
You make the 4 vacuum in the range.
Yes, has to be a bracket because there will never be an open dot on one of these. All right. What if the equation is not in standard form? You have two options. One is force it to be in standard form, and this process is called completing the square. So you have two options. You will be forced to complete the square, so you're going to need to know this either way. You just, if I give you another option to just graph it, you might not have to do this method. I'm going to teach you a second method. But at some point, you are going to be completing the square on both your quiz and your test. To complete the square, and this is like one of those things people are like, I don't know what this is, but then when I work it out, sometimes it looks familiar. So I'm hoping that's going to happen. If you have two terms, you're going to group the first two terms together, and then you're going to leave a space for a third term that you're going to find. So this is this step. Actually, let me write this right next to it so that it's in line with it. So step 1 is group the first two terms together. ax squared plus bx, leave the space, plus c. Whatever those numbers are, obviously, will be filled in. If a is not 1, then we have to take it out. So if it's a negative, it comes out. If it's a number, it comes out. If it's 1, we don't worry about it. So we would take out the a, and when we take that out, it comes off of both the first and the second term. So this would end up being b over a. And again, you'll see that when we divide it into it. Because you're going to have to, if there is something in this term, like let's say there's 2 here, I have to take it out of the parentheses, and by taking it out, we have to take it out of every term that's in here. So it comes off of this one and this one.
And then dividing it?
You would be dividing it, yeah.
Wait, why? Like, why did we take it out?
Because you can't complete the square if that is not if that's not x squared. The first one has to be an x squared. We're forcing it to become a perfect square trinomial, and the perfect square trinomial with an x squared at the front. It's the only way the process works.
So if it's not a 1,
Then we take it out.
Then you take it out.
Yep.
What happens if it is like that?
Then you don't have to take it out. Then you skip step. Then you, like if this is 1, this is 2. Then you skip step 2. Yep. Then you do what we call completing the square, which is taking the second term, taking the b, dividing it by 2, and squaring it. And then we will add that inside the parentheses and subtract it outside the parentheses to balance our equation.
You add it.
So we add inside the parentheses, we subtract outside the parentheses.
You subtract from the c.
From the c. Yeah, because we got to balance out this equation, right? I can't just add something in here. It changes the value. So I got to add it in here but subtract it from here.
It's a plus.
It's a plus inside the parentheses. It's a minus outside. Now, when you did this in Algebra 2 Honors, you would have added to the right side of your equation. You would have added to the left side of the equation to balance it. But we want to keep this in function format, so we're always going to keep everything happening on the right-hand side. So we add and subtract on the same side.
Is this b over 2 because that's the number that you gave us?
No, it is always b over 2. So whatever term is in the middle there, you're going to divide by 2 and then square it. And that's what we add inside that blank that we filled, and we subtract from the c. Now, if there was something that we took out, which I'll show you, but if we took out something out here, like if it wasn't just a 1 and we took something out over here, we have to multiply that by whatever this is before we add it over here. So I'll say that again. If we took a number out here, we would have to multiply that number by whatever we get from this before we subtract it from the outside. Again, we're going to practice this, but those are the steps. And then we're going to factor what's left to get our standard form. And to factor your perfect square trinomial, you square root the first term, you square root the last term, and you take the sign from the middle term. That's your shortcut for factoring a perfect square trinomial. You put it in parentheses and you square it.
When you factor out the a, why doesn't it affect the c?
It affects the c when we add it back in.
Oh,
Does that make sense? So we group these, right? We put those in parentheses. We're taking the a out of this parentheses, so it only affects the b. But then when we go to add this at the end, that's why we have to multiply it by the a, because it has to correct it.
right.
Does that make sense? Okay. Marianne.
So when you put it into the middle, when you add it to the middle and subtract it to the end, is it b over 2 or b over 2 squared?
B over 2 squared.
Okay.
Why did you do that at the end?
Because the whole goal here is to force it to become a perfect square trinomial, so we factor it, and it looks like this. We want it to look like that at the end, because that's standard form, right? Then we would be back to where we started on example 1, 2, 3. where we know the vertex, find our intercepts, all that stuff.
Then why'd you do the other thing?
What other thing?
The first, last.
This is how you factor it.
Oh.
That's how you do it. Yeah. All right, so some people are good with words, but most of us are better at the practice, so we're going to do that. So example 4 says to write it into standard form, identify the vertex, axis of symmetry, x-intercepts, and then graph. This is not in standard form, right? Because we have an x squared and an x. That's how we know the difference. So this is in quadratic form. So the first thing we're going to do is force it into standard form. So we're going to group together our first two terms. I'm going to do x squared minus 14x, leave the space because I'm going to fill it in, plus 54. Is there something in front of an x squared? No. Yay, of course we're going to baby step our way into that crap. Okay, I'm taking it slow. So I look at b. What is b? 14, and it doesn't matter if I say negative 14 or positive 14 because I'm going to square it. So I ignore the negative until we get to the end to factor it, okay? I'm going to take that 14, I'm going to divide it by 2 and then square it. So 14 divided by 2 is 7, and 7 squared is 49. I'm going to add the 49 inside the parentheses and subtract it to balance the equation from outside the parentheses. So I've got f of x equals x squared minus 14x plus 49 plus 5.
Why didn't you take out the x?
You take out whatever's in front of the x. Is that what you mean? This thing?
No.
Only if there's something in front of the x. Yeah.
I thought it.
You're taking out the a, so the a is what's attached to the
So
x.
it's technically like a 1 in front of x.
So anything other than 1. 1 won't change anything. Now I factor, right? So we said we're going to square root the first term here. Square root of x squared would be? Square root of the last term. Sign from the middle. Put it in parentheses and square it. That process is called completing the square. So we took something that was not a perfect square, we forced it into a perfect square, and then we put it in standard form. So now we're pretending that this is the question that was given because we know exactly what to do with this. What's my vertex? 7, positive 5. Good. Does this parabola open up or down? Up. What's my axis of symmetry? Oh, so close. X equals 7. It's the x coordinate of my vertex. That I already know, right? Okay, now let's try our intercepts. X-intercepts, Y-intercepts. So my x-intercept, I'm going to say 0 equals x minus 7 squared plus 5. Subtract the 5. Square root. What happens when I square root a negative 5? It's imaginary, which means it's not possible. There are no x-intercepts. Y-intercept. Y equals 0 minus 7 squared plus 5. Y equals negative 7 squared plus 5. 49 plus 5. 54. What do you know is about the y-intercept and my original equation? It's the c. If I'm given the equation in quadratic form, my y-intercept is the c. It's the number that's all by itself. Because if I plug in a 0 here and I plug in a 0 here, that's going to be the only thing left. So I think it's easier to find the y-intercept from quadratic form than from standard form. You could do either one, okay? But if I gave you the question in in quadratic form, I tell you to put it in complete the square, then you have your choice. You could either go back up to the original question, that would be zeroed out, that would be zeroed out, this is my actual k, or I can plug 0 in here, you should get the same answer. Yep.
Why is the vertex not negative 7?
It's the opposite of what's inside the parentheses.
But the outside stays the same.
Outside stays the same.
Okay.
Yep.
How would you graph like to 0?
We're going to do
I don't
it.
know if you just said that.
No, we didn't. Yeah, no, we didn't do it yet. All right, so I'm going to graph my 7, 5. Now think about the standard form of this equation. What do I know about it based on its transformations?
It goes
It goes up, which is consistent, right? I don't know. It goes to the right 7, it goes up 5, and it points up, which is consistent with not having x-intercepts, right? So all that stuff you already know about transformations, use that to help you make sure you're on the right track. My y-intercept is at 54. Good God, I don't want to graph that, right? All the way up there, which means this is an opportunity to plug in extra points. Does that make sense?
Would we have to?
Yeah, because we don't have 3 yet.
You
Have to have 3, and including 1 to the right of the vertex and 1 to the left. So if I had 3, but they were all on this side, no. You have to have 1 to the right and 1 to the left.
If we had x-intercepts,
That's
we
3.
would count.
Correct.
So we would do like 6 and 8.
So I would pick 6 and 8 because those are going to give you the smallest numbers. Otherwise, they're going to the further you move away, the bigger they're going to get. And guess what? You have choices. You could plug it into this equation or plug it into this equation. Standard's going to be a lot easier because I don't want to square 6 and then multiply 14 times 6. Vanessa.
So does the vertex count as number?
It does. So I'm going to plug in 6 and I'm going to plug in 8. What do we think is going to happen with both these answers? They should be the same because it's reflective over that axis. So negative 1 squared plus 5, 1 plus 5, which is 6. 1 squared plus 5, 1 plus 5, which is 6. So my 2 coordinate points are 6, 6, and 8, 6. And then again, it would keep going all the way up to 54 for my y-intercept, but you do not have to graph that as long as you have the other points.
Do we have to show the work of the extra points?
You got to give me at least 1 point. Yeah, you can reflect it. So my advice would be if you have the time, make sure you plug both in because if you screw one up, you screw the other one up. But if you're like running out of time, feel free to use your symmetry to reflect that point. Yep. I'd rather you give me a graph than nothing. Mm-hmm.
So I always get confused, like, how should you know which are the best points to plug in?
I go closest to the vertex, the one to the left and the one to the right.
Okay.
Yeah. Because if there's no vertical stretch, it should just be 1 unit up and 1 unit up in each direction. So that's not hard. That shouldn't
You
be.
could just do like the closest one.
Mm-hmm. Yeah. If you want more, you can plug in more, but you don't need it. How we doing? Next. It did, because it should. You're speechless. That's fantastic. Yeah. I wowed you. Yeah. Okay. So here's your other option. That is one way to take an equation that's in quadratic form and graph it. It's to force it in to complete the square. The other way is to keep it in quadratic form and use what I call it the negative b over 2a method. It doesn't have an official term, okay? But you will leave it in this format. You will find the vertex by saying that h is negative b over 2a. So I would take that b, I would make it negative, and then I would divide it by 2 times a, and that's my h coordinate of my vertex. I don't change the signs like I do with h from the equation. I keep it the way that it is. It says 2a, yep.
If you don't change,
No, so if I look back on the last example, what was it? 1454, right? So the negative b would be negative 14 over 2 times a, which is 1. Negative 14 over 2, and that's negative 7. That's the same coordinate I got the last way, right?
If you use, if it said negative 14,
Oh, wait, it did say negative 4. The same, yep. I would get 49 minus 98 plus 54. That's negative 49 plus 54, which is 5, and 7, 5 was my vertex.
so that's to find k.
That's to find k, yep. Okay, so think about it now. I already know which direction this faces because it was a positive x squared, right? I know my vertex using negative b over 2a and plugging it back in. I know my axis of symmetry because it's x equals h. As soon as I know that h, I know that. And we're going to talk about it eventually too, but I also know my maximum. My maximum is the k coordinate of my vertex. So all those things I know just by doing negative b over 2a and then plugging it back in to get the vertex. I also could determine my domain, my range. All that stuff can already be determined without even having the graph, okay? Then I would find the intercepts, and then I would use any other points I need. okay, if I needed it to plot the points. Now this time when I'm finding my intercepts, so it would be 0 equals x squared. Let's say I use the one we just did because we already know the answer. This is, instead of having to do the even root property, because I don't want to force it in to complete the square, I would have to either factor it or use the quadratic formula. So are there factors of 54 that sum to negative 14? Think about 54. Would be 1 and 54, 2 and 27, 3 and 18, 6 and 9. Do any of those add up to 14? No, which is consistent with the fact that we didn't have x-intercepts. This would be prime. Okay? If you can't factor it, you can move on to the quadratic formula, which is negative b plus and minus the square root of b squared minus 4ac over 2a. In this example, what's underneath the square root will be negative. So it wouldn't be able to be found that way. This would have no x-intercepts. So you'd have to plug in your extra points. This is how you can solve any quadratic, meaning anything that is squared, whether or not it is factorable. So you are going to get times in which your coordinate points are whole numbers and it was factorable, and you're going to get times in which it's not. No, factoring is so much faster. Like if that was a 15 here, I would say, or like a negative 15, I would be like negative 15, positive 1, done. But if I have to plug it in there, it takes a lot longer.
So that's if there's no factor.
That's if there's no factors. Or it's not obvious factors. Like you can't get them because maybe it's the number like 48 where it's 1 and 48, 2 and 24, and there's a lot of different combinations to try. Then you can use quadratic.
But quadratic formula will give us a
Quadratic will always work. Yep. It might give you a negative underneath and then you know there's none. But it's not like a trial and error where it was with factoring. Did you was that your hand? Yeah.
But so what would you need to use those formulas for the quiz?
There are times when on the quiz I think I made it factorable. But there are times when you're going to have to use the quadratic. And it's so important to know quadratic for standardized tests, so it's good to review it. But I'll double check, and I'll let you know for sure before Thursday, but I'm almost positive I made them all factorable for now. You're welcome. I'm not making any promises by test, but for now. All right. We're going to do this one because what's different between this and what we've already done? There's two things happening here that are yucky. One, there's a negative on the front. Two, the middle term is not even. Ew, you're going to have fractions. You'll survive, I promise.
Wait, so for this one, we're using like standard form and we're completing the square.
So it just wants you to find the vertex of the function. We're going to use complete. Well, you can do either way. You can either do complete the square. I'm going to show you both. You could either do complete the square to put it into complete the square and take out the vertex, or you could do negative b over 2a, plug it back in to get the k.
And what is that?
That's the faster way.
But what is it called?
I call it negative b over 2a. It doesn't have a name.
Okay.
Yep, it's just keeping it in standard in quadratic form. All right, so I want to practice complete the square, so we're going to do that way as well. So I would group together the first two terms. Now I got to take out that negative, right? So negative comes out. Changes the sign of both of those. So it takes the negative off the x squared and it changes the sign of the negative 3x. Now to find that third term, I have to do 3 divided by 2 squared. And that gives me 9/4. I add it inside the parentheses. And normally I would subtract it from outside the parentheses, but I took something out of the parentheses, so I have to multiply that before I combine it with the k.
Why don't you add the negatives to the term inside?
Because it's always going to be squared, so it's always going to be positive. So instead of subtracting this time, I am actually adding the 9/4.
So would you get rid of the negative?
No, it always stays there because it's part of the equation. Good question. So now I have negative x squared plus 3x plus 9/4, and then 7 becomes 28/4. And this is 37/4. Now I forced it into a perfect squared trinomial, so I would keep the negative there. Whatever's on the front still has to be there. Square root the first term, square root the last term, take the sign from the middle, put it in the parentheses, square it, and there's your k.
The k is negative 3/2.
No, the k is positive 37/4.
Oh,
So what's the h for 3/2?
Negative 3/2, right? Because we changed the sign on the h.
So the one in the middle changes.
Correct.
One on the opposite.
Correct. Because think about it. Your horizontal shift, we go in the opposite direction. Right? Like when you shift it, if it was a plus inside, we went left. If it was a negative, we switch it. But the k, the one that goes up or down, it stays true to the sign. Yep.
On a test, do you have to like change it from an improper fraction?
If you were to graph it, yes. If you're just giving it to me, no. Like if I have to graph that point, obviously I got to make that 9 1/4. But if not, no. Yeah. 2p.
Find the vertex on this one, we're able to use negative b over 2.
Yeah, so I said I was going to do both ways. So you practice because we hadn't done a complete the square with a negative. So that's the complete the square part. Again, the quiz is going to force you to do that for a question. It's going to say complete the square. Put it in standard form. But our other option, which I think is faster in this way, especially when you've got, so I look at this middle term and the first term. If the first term has something I have to take out and I have a choice, I'm going to go negative b over 2a. If the middle term is not even, I go negative b over 2a. If not, it's not that big of a difference to me. But I approach it that way. So if I want to do negative b over 2a, negative 3 over 2 times negative 1 would be 3 over negative 2. There's the x coordinate of my vertex, and it matches what we already found. Then I have to plug that back in. So negative 3 halves squared minus 3 times negative 3 halves plus 7.
wait, I'm sorry. The negative 3/2, you plugged it back into x. So
Yep.
we're finding, okay.
Now I'm going to find the y, which is the k.
And how did you know that was your h?
Negative b over 2a is your h.
Oh.
Yep. So negative 9/4 plus 9 halves plus 7. Give them all the same denominator. So negative 9/4. I'd have to multiply by 2, by 2, by 2, by 2. Nope, sorry, by 4, by 4. This is 9/4 plus 28/4, 37/4. So I want to stress that you'll never have to do them both ways. Zoom in. You'll never have to do them both ways. But you want to be prepared to flip back and forth. It's going to force you to do complete the square. It's going to give you just in quadratic form, and it would be easier to do negative b over 2a. Okay. When there's stuff like word problems that say like use this to find the max, that's when you're going to want to do negative b over 2a, plug it back in. It's way easier than doing complete the square. All right, this we started to talk about at the beginning, but we didn't officially have it written. This is where it's different from what we did before in the last chapter, because we are now talking about an absolute max or min. There is only one of these. If my parabola opens upward because the a is positive, then I have a minimum. And if it opens downward because my a is negative, I have a maximum. And this time, it's just the k. So it is only the y coordinate of your vertex. You will only give me one coordinate point. I mean, not a coordinate point. You will only give me 1 point here. And it's the y coordinate of your vertex. So for that last one, it would have been 37/4. That would be my max. Wait, yeah, because it would open downward. It would have been my max. I just want to show you, actually, I'm going to start it. I'm going to show you, because we haven't done a complete the square with the -3 in the front, I'm going to show you the complete the square with it, okay? And then if not, but on this is one of those I would recommend doing the -b/2a. But you are going to have, if you don't have that option, which you won't on the quiz, it's going to say complete the square. You have to walk through this process. So I'm going to complete the square on this. -3x squared plus 2x, leave the space, plus 5. Now what? Take out a -3, x squared. So it gets divided from this and from this, which means it's -2/3 x. Now I take my 2/3. Good? Yeah. Divide it by 2, which is the same thing as multiplying by it a half. I get 1/3. And then square it, and I get 1/9. So I took 2/3, I divided it by 2, or the same thing as multiplying by a half, which is 1/3, and then square it, you get 1/9. And that's what you're going to add in here. Sorry? You always take b, divide it by 2, and square it. Now I would normally add it there and subtract it, excuse me, from here. I'm over it too. But I took something out, so I have to multiply this by the -3 first, which makes this become positive 1/3. So I've got -3 x squared minus 2/3 x plus 1/9 plus, and you could keep it, mixed number, 5 and 1/3 is easier this time. Or you could change that into an improper fraction, totally fine, either way. 16/3, same thing.
Do you know if what the sign was gonna get?
It won't matter. Actually, that's a really good question. I think it keeps it improper. Yeah. Now I gotta factor it. The -3 stays on the front. I square root the first term. I square root the last term. I take the sign from the middle, put it in the parentheses and square it. And then I think WebAssign would have it like this. But that's the equation. So WebAssign's gonna ask you for the, I don't think you can put the mixed number in. I think it has to be improper. So this would be standard form. So what's my vertex? 1/3, 16/3, right? My x-intercepts, I would plug 0 in for y. Where do I want to do that? The x-intercepts, I plug 0 in for y. Where do I want to do that? It's up to you. You could either plug it in up here and try to factor it, right, if you're good at factoring. Or you could plug it in down here and have to do the even root property. It's completely up to you. So if this was 0, I'd subtract the 16/3.
This is for additional points
This is for the x-intercepts.
and the y-intercept.
It didn't ask for it, but you could find it, yeah. Divide by -3, which is the same thing as multiplying by a -3rd. I get 16/9. I square root both sides, putting a plus and minus in front of it. And then I'm solving it using even root because I made y 0. It asked for the x-intercepts. The 1/3. So this is two equations. -4/3 equals x minus 1/3, and positive 4/3 equals x minus 1/3. Yeah, hang on. Add the 1/3. Add the 1/3. So -3/3, which is -1, 5/3. Those are my two y or x-intercepts. So I would have gotten the same thing if I factored. My y-intercept, I would just plug the zeros in, right? And it would be that last number. I can't even remember what the last number is. Would be 5. It would be 0, 5. So that's hopefully easy, and I would do that from quadratic form.
When you get the y-intercept in the equation, you use the sign it as?
Yes. Because it would be 0, 0, right? And then you keep the last one.